Hey all, so this is one of those other lessons. We had one earlier in the year where I didn't include notes in the packet because so many students have already seen this before that I generally don't actually teach this with notes, but I figure since it's distance learning and I do want you to practice this idea, I would include a video. If you want to print out the PDF, you can. You can also just take notes in your homework notebook just like you normally would. And if this feels really familiar, you don't even have to take notes at all. This is one of the optional notes assignment, though of course the homework and the practice in the book is not. Just spend your 30 minutes in the way that makes the most sense to you. So let's get ourselves started. We're going to talk about the triangle angle sum theorem, and we'll use that to solve for the missing angles of a triangle. So this is a fancy name for something that you are hopefully familiar with by this point, which is the idea that the angles of a triangle will always add up to 180 degrees. Now, one thing that I will use in this is maybe a little bit more algebra in our solving. So I'm going to show you a way that I think is really helpful for solving these more complicated questions like what we see in number 2 here, but also work just fine for simpler, more basic problems like number 1. So for both of these, it asks you to find the value of x. And we're going to use the triangle angle sum theorem, and I'm going to write it out very literally, saying that all the angles add up to 180. The angles in the case of number 1 are x and plus 96 plus 21 equals 180. Most of you probably wouldn't solve it with an equation like this, but it's going to make problems like number 2 much easier if you have this practice. So then what I'm going to do is I'm going to combine the like terms, the ones that don't have an x. So then this turns into x plus 117, 96 plus 21, equals 180. Now I want to solve for x, so I subtract 117 on both sides since it's being added. And now I have x by myself over here, and I'm going to do subtraction, got to do a little borrowing here, 7, 10, I end up with 3 and 6. So x is equal to 63, and it's an angle, so I'm just going to tuck a degree sign right up there. This problem, number 1, is hopefully what a lot of you are familiar with. Number 2 is a much more challenging version, but we can use the exact same method as we just did, where we write out each angle separately, like what we see here, x plus 96 plus 21. We're just going to use these more complicated terms and set equal to 180. So in this case, I'm going to say 3x minus 17, first angle, plus x plus 40 for my second, plus 2x minus 5 for the third angle is equal to 180. And in this case, the equations are really helpful. And again, the next thing I'm going to do is combine my like terms. I have 3 terms with x. So my x terms combine 3x plus 2x. Those are all my like terms that'll go together. And then we have our constants. And notice we have 1 each for those as well, the non-variable terms. So plus, and the negative 17, because it is negative, don't forget that. And 40 minus 5, because again, negative, so watch out for your negatives, equals 180. I will combine our like terms, so we've got 3x plus 2x. Remember, we treat x by itself as 1x, so 3 plus 1 plus 2 is 6x. Plus, I would maybe even just change the order around here as 40 minus 5 minus 17, which is 18, is equal to 180. From here, I'm going to subtract 18 on both sides, and I end up with 6x is equal to 162. And to get x by itself, I'll divide by 6. And I don't know 162 divided by 6 off the top of my head, so I'm just going to do a quick little scratch problem. So when we say scratch work, we mean things like this. I'm not going to grab a calculator. I'm going to do a little long division. 6 goes into 16 twice. 12, subtract 4, carry down the 2. 6 goes into 42 7 times. And there's no remainder there, so I know I'm done. X is therefore equal to 27. Like so. Now toss the degrees on. That's also great. So this is why I prefer writing it in equation form, is it makes problems like this that are much more complicated, much easier to do, because you're just going to combine your like terms and solve from there. If you have questions, please let me know, and I look forward to hearing from you.